Solve the recurrence Tn equal to 3 Tn by 4 plus theta n square. Let us apply the iteration method. So apply the iteration method. We can write Tn equal to 3 Tn by 4 plus theta n square as Cn square. This is the first equation. Then for the second equation we have to replace this Tn by 4. So is equal to 3 into, we are replacing Tn by 4. So every stage the problem size is 1/4 of the previous problem size. Okay, so n by 4 by 4 it will be n by 16 plus n by 4 here, then n by 4 into 4 equal to n is coming here. Okay, so n by 16 into 4 it is n by 4. So C n by 4 whole square plus this is the replacement of Tn by 4 to the next level. Then Cn square is there, Cn square. Okay, this will be equal to 9 Tn by 16 plus Cn square plus Cn square, this one 3 into C n by 4 whole square. Okay, so 3 into C n by 4 square. This is the second equation. Then the third equation will be 9 T n by 16. So here we are T of n equal to 9 T n by 16 plus C n square plus 3C n by 4 whole square. 9T n by 16 plus Cn square plus 3C n by 4 square. This is our second equation. Then let us consider next stage also. So let us replace T n by 16. So it will be replaced by 3 T n by 16 into 1 by 4. It will be 64. That is n by 16 by 4. N by 64 plus C n by 64 into 4, or the previous problem size n. Okay, it is n by 16. So n by 16 square plus Cn square plus 3Cn by 4 whole square. This will be equal to 27 Tn by 64 plus, okay, let us write these terms first. So it will be Cn square plus 3Cn by 4 whole square plus here 9C n by 16 whole square. Okay, 9C n by 16 whole square. This will be our third equation. Okay, let us generalize this. Let us try to generalize this. In general, when the equation is 3, equation number is 3, it is coming 27 here. So this 27, this can be written as 27 is equal to 3 raised to 3. Okay, and here it is coming 64. 64 is 64 equal to 4 raised to 3. Okay, and here you can see 3n square, 3 cn by 4 square, and here it is 9. So 9 is nothing but 3 raised to 2. Here I can write 3 raised to 1. Okay, so this part is a summation. Okay, so this part in every equation, this part is a summation. We can write it as some sigma. Okay, some sigma. Okay, in the first equation, let us see the first equation. It is only cn square. That is when the equation number some k equal to 1, we are getting cn square. When k equal to 2, two terms are coming. 3 raised 3 cn by 4 square. So I can write 3 raised to 1. Okay, 3 can be written 3 raised to 1 here. Here I can write 3 raised to 0. Okay, let us write all the equations together. The first equation is T of n equal to 3Tn by 4 plus Cn square, the first equation, and the second equation is uh, 9T n by 16 plus Cn square plus 3Cn by 4 whole square. This is the equation number 2. And equation number 3 is 27T n by 64 plus Cn square plus 3Cn by 4 whole square plus 9Cn by 16 whole square. This is our third equation. Okay, so we have to write what is in general for some equation number k. Okay, when the equation number k equal to 1, that is when k equal to 1, this part I can write 3 raised to 1. Here 3 cn square is coming. Okay, here I can write 3 raised to 0. See, in when equation number is 2, here 3 raised to 2 minus 1. I can write 3 raised to 2 minus 1. Here I can write when equation number is 1, 3 raised to 1 minus 1. 1 minus 1. Okay, so 3 raised to 0, it is 1. 3 raised to 0 into 3 cn square. In the third equation I can write Here it is 3 raised to 3 raised to equation number 3 minus 1. Okay, in general I can say it is k 3 raised to k minus 1. Okay, so this is a sum up, isn't it? This part I can write it as a sigma. Okay, so sigma, so here 1 minus 1 it is 0, then when it is 2, this term plus 3 raised to equation number minus 1. Okay, and here I can write when equation number is 2, only two terms are coming, that is 0 to equation number minus 1, or I can write k minus 1. Okay, so I can write this part as sigma sum I equal to 0 to k minus 1, 0 to k minus 1, 0 to k minus 1. I can write it as 3 raised to I. Okay, when 3 raised to I, 3 raised to I, C, then when the equation is 2, we are getting n by 4. When equation number is 3, we are getting the last term n by 16. So in general I can write n by 4 raised to I. Okay, when n is equal to 1, I can write n by 4 raised to 0 whole square. Okay, okay, so this part I can write it like this, and this part I can write it as 27. Equation number is 3, it is 27, so 27 is nothing but 3 raised to 3. Okay, so it is 3 raised to k. In general I can write k is the equation number, then t n by in equation number sorry, it is 27 t n by 64. Okay, not 16. Okay, it was n by 64. So when it's 2, it is coming 16. When it is 3, it is coming 64. So I can write n by 4 raised to the equation number 4, n by 4 raised to k. Okay, so in the general equation will be t of n equal to 3 raised to k t n by 4 raised to k plus sigma I equal to 0 to k minus 1, 3 raised to I, c n by 4 raised to I the whole square. Okay, let us check the first equation. That is when k equal to 1, we should get the first equation. Then k equal to 1, what should happen? T of n equal to 3 raised to k equal to 1, 3 raised to 1. Okay, then t of n by 4 raised to k, 4 raised to 1 plus sigma I equal to 0 to k minus 1. K is 1, so k minus 1 is 0. 0 to 0, only one term. That is 3 raised to I is 0. C n by 4 raised to I is 0, so 4 raised to 0, 4 raised to 0 the whole square. So this will become 3 t n by 4 raised to 1 is 4, n by 4 plus I equal to 0. So 3 raised to 0 is 1. So 1 into c, it is c. N by 4 raised to 0 is n. So cn square. Okay, we are able to generate the first equation from the general equation. Okay, let us check what is happening when k equal to 2. K equal to 2. We should get the second equation. Okay, so when k equal to 2, t of n equal to 3 raised to 2 t n by 4 raised to 2 plus sigma I equal to 0 to k minus 1. K is 2, so k minus 1 is 1. 0 to 1. So I should first I will be 0, then I will be 1. Okay. So then 3 raised to I c 3 raised to I c n by 4 raised to I square. Okay. So this part will become 9. This part will become 9 t n by 16. Okay, that's correct. Then what about this part? What will happen when I equal to, so I should take two values, I equal to 0 and I equal to 1. So when I equal to 0, you will be getting, as in the previous case, 3 raised to 0 into c, so it will be c, then by 4 raised to 0, 4 raised to 0 is 1, so n by 1 is 1, so n square. Okay. Then I equal to 0, I equal, then what will happen, I equal to 1, I equal to 1, 3 raised to 1, 3 raised to 1, c n by 4 raised to 1 whole square, it will be 3c n by 4 whole square. So the when k equal to 2, that is the second equation, 9t n by 16 plus I equal to 0, you will be getting 3c n square. Then I equal to 1, you are getting 3c n by 4 the whole square. Let us check what was our second equation. See, 9t n by 16 plus c n square plus 3c n by 4 whole square. Okay, so the general equation is correct. Our general equation is Tn 3 raised to k Tn by 4 raised to k plus sigma I equal to 0 to k minus 1 3 raised to I c n by 4i whole square. Okay, next let us think about the last level. Our general equation was T of n equal to 3 raised to k t n by 4 raised to k plus sigma I equal to 0 to k minus 1 3 raised to I c n by 4 raised to I whole square. This was the general equation. Okay. Then in the last stage, the problem size in last stage, problem size will be 1. Problem size is equal to 1. That is, in the last stage, Tn by 4 raised to k will be T1. Okay, that is n by 4 raised to k will become 1. That is our problem size is n by 4 raised to k. So this will become 1. That means our k is equal to the level number k will be log n to the base 4. So our equation will become T of n will be 3 raised to k is log n to the base 4 T1 plus sigma I equal to 0 to k is log n to the base 4 log n minus 1 3 raised to I c n by 4 raised to I the whole square. Okay, we can say when problem size is 1, this will take some constant or constant value as the cost. So I can write it as c into 3 raised to log n to the base 4 plus this will be cn square plus 3c n by 4 whole square plus what will be the last term when k equal to log n minus 1, this will become 3 raised to log n minus 1 c divided into n by 4 raised to log n minus 1 whole square. Okay, that is the last term, and here we can see the term cn square. It is the biggest term. Okay, so we can write it is big O n square. The complexity will be big O n square. Next, let us think about the iteration tree method. Our equation was iteration was 3t n by 4 plus theta n square. I can write it as cn square. Okay, so the tree will be n, then n will become 3n by 4, 3tn by 4, so 3n by 4 problems. N by 4, then another n by 4. Then this n by 4 problem will become 3 n by 16, n by 16 and n by 16. 3 n by 16 problems, and each n by 16 problem will become 3 n by 64, n by 64, n by 64. So this is the structure of the tree, and in every root, every intermediate root, the cost is c into the problem size square. Okay, so here the problem the cost is cn square Here the cost will be uh, 3 problems of size n by 4. So the cost will be here it will be Cn by 4 square, n by 4 square. Here it will be Cn by 4 square. Here also Cn by 4 square. So it will be 3 Cn by 4 square. And here how many? See, every n by 4 problem will become or will be split to 3 n by 16 problems. Okay, so this will split into 3, this also into 3, this also into 3. So 3 into 3 into so 3, every problem will be split into 3. So total 9, 3 plus 3 plus 3, it will be 9. So cost will be 9 into C n by 16 square. Okay, we have n n by 4 n by 4 and each n by 4 into 3 n by 16 n by 16 n by 16. Okay, then cost here is C sorry not 2 it is 3 n by 4 3 n by 4. Okay, the cost is Cn square. Here the cost is 3Cn by 4 square. Here cost is 9Cn by 16 square. Okay, finally the tree size will be reduced to 1. So in the last stage you will be getting problem size 1, that is every node with one element. Okay, then what is the cost of this level? This is a special case, isn't it? In general, in some kth level, I can write the cost as 3 raised to the level number. This is level number 0, this is level number 1, this is level number 2. So in general I can write 3 raised to level number 3 raised to k C n by 4 raised to k the whole square. This is the cost, and the problem size at level k is n by 4 raised to k. Okay, problem size is n by 4 raised to k. So at level k problem size equal to n by 4 raised to k, and number of problems at level k equal to, what are the number of problems at level 1? It is 3, isn't it? 3 problems, each of size n by 4. So that is I can write 3 raised to k. Okay, what are the number of problems in level 2? It is 3 raised to 2, 9 problems, isn't it? Each n by 4 is split into 3. n by 16 problems. So 3 into 3 into, so 3 plus 3 plus 3. Okay. So 3, I can write 3 raised to 2. So general 3 raised to k. Okay, so 3 raised to k problems. So number of problems at level k, at level k equal to 3 raised to k. Okay. So in the last level, problem size equal to 1. That is, in the last level, problem size equal to 1. In the last level, problem size equal to 1. That is, n by 4 raised to k is equal to 1. N by 4 raised to k is equal to 1. K equal to log n to the base 4. Okay, log n to the base 4. Then what are the number of problems? What are the number of problems? 3 raised to k. So number of problems at last level, at last level equal to 3 raised to k. Okay, since k is equal to log n to the base 4, we can write it as 3 log n. 3 raised to log n. 3 raised to log n. Okay, then cost of a problem. Cost of a problem, we can write it as problem size is 141. We can write it as some c. Okay, then total cost at last level is equal to problem cost is c. How many problems? 3 raised to log en to the base 4. Okay, so this is the cost at last level. This is a special case. Then let us come back to the tree. Okay, what will be the total cost? Total cost is sum of the cost at each level. So this will be T of n equal to Cn square plus 3C n by 4 whole square plus 9C n by 16 whole square plus cost at last level. What is the cost at last level? It is c into 3 raised to log n to the base 4. Okay, and this cn square is the biggest term. It is contributing more, so we can write the complexity is big O n square.